welcome to Algebra 2. This is Lesson B. We're going to talk about perimeter, area, volume, surface area, and the sectors of circles. We're starting on page 8. Continuing our review of geometry, first we'll talk about perimeter. The perimeter of a closed planar geometric figure is the distance around the figure. So to find the perimeter of this polygon, we would add up the sides. So 3 plus 3 plus 4 plus 2.5, which equals 12.5. And we're going to say these were actually centimeters. So this will be centimeters. Okay? The perimeter of a circle is called the circumference of the circle. So the circumference is the area all the way around. The radius of a circle is the distance from the center of the circle to the outside of the circle. Actually, to any point of the circle. Any point of the circle is the same distance away from the radius. Okay? A secant is a line that passes through a circle. So if this line passes through a circle, it's called a secant. A chord is the part of the secant that's left inside the circle. So a secant is the whole line passing through the circle. The chord is just the part that goes from both edges of the circle and in the inside. Okay? The diameter of the circle is a chord that goes all the way through the center of a circle. So in this circle, this would be the diameter. Or this is the diameter. The diameter is 2 times the radius. The circumference of a circle is 3.14 ... diameters long. We call that number pi. And we use this Greek symbol. So, the circumference of a circle is pi times the diameter. Since the diameter is 2 times the radius, this also equals 2 times pi times the radius. And this is the formula we use the most often, 2 pi r. Okay? To write pi as a decimal would take an infinite number of digits because pi is an irrational number. So for extra credit, you can recite to me the digits of pi to at least the 10th decimal place. Okay? Most of the time when we do problems involving pi in this book, you may leave your answer in terms of pi instead of giving the decimal equivalent. So unless the book asks for the decimal equivalent, if this radius were 2 centimeters, then to find the circumference, we could say the circumference, I can't write, equals 2 pi r. The r is 2, I wrote meters, so 2 meters. So that would be 2 times pi, which equals 4 pi meters. You need to put the meters there. You do not have to pull pi out. You can just leave it as 4 pi. Okay? Okay, now we're going to talk about area. The area of a flat, closed geometric figure is a number that tells us how many squares of a single unit size it would take to cover the figure, or how many squares the object is covering. So, this rectangle is 4 centimeters wide and 2 centimeters long, or wide in length. It doesn't matter really. To find the area, we're going to multiply the length times the width. So the area is going to equal 2 times 4, which equals 8. Since we're doing area, really what we're saying is that there are squares inside, so we're actually going to say it's 8 centimeters squared. Okay? When you're doing any of these problems, putting the units here and having the units correct is just as important as having the value correct. If you are in my class, if there is a problem and it has a unit, if your unit is not there, your problem is half wrong. Okay? And that's going to be true for the entire year. Units are very important. Remember to use them. The area of a circle is pi times the radius squared. So here we have a circle and the radius is 2 centimeters. So the area is going to be pi times 2 squared, which equals 4 pi centimeters squared. Once again, you can leave this in terms of pi. You do not need to pull it out into a decimal. Okay? The area of a triangle is 1/2 times the base times the height. The base is this part down at the bottom. The height is how tall the tallest part is from the base. And we measure that with a perpendicular line. So if we have a right triangle, then the height is just going to be the height of the right triangle. Okay? So in this case, we're going to have 1/2 times the base, which is 4, times the height, which is 3. 1/2 of 4 is 2 times 3 equals 6. So this is 6 units squared. I didn't say if it was centimeters or inches or feet or meters or miles or kilometers. So it's 6 units squared. Okay? Here is a different kind of triangle. This is not a right triangle. So the height is going to be from a line from the center of the base to the top of the point at a 90-degree angle with the base. Okay? So in this case, the base is 4 and the height is 3. So we're still doing 1/2 times 4 times 3, which is still 6. Here we have an obtuse angle. In this case, we're not going to take the height from the middle of the base because that's not the highest point. So we're going to make a line from the highest point down to the same plane, the same place as the base, so that the height, or the altitude here, is still at a right degree angle to the base. It's still perpendicular to the base. Okay? So all 3 of these triangles have the same area. Okay, here's a funky a funky polygon. Let's find the perimeter and the area of this figure. Okay, when we have complicated shapes like this, we're going to start by subdividing the figure into shapes that we can work with. The problem actually says that lines that look parallel are parallel, and the dimensions are in meters. Okay, so when we start subdividing this figure, we can put a dotted line here, and here we have a half circle. Pretend it's straight. Okay, if we put a dotted line here, then we have a rectangle and a triangle, and this triangle is a right triangle. Okay, let's start with the area of the half circle. So the area of a semicircle is going to be half the area of a full circle. So this is going to be 1/2 times the area of a complete circle is pi r squared. Okay? The radius here is 2. So this is going to be 1/2 pi times 2 squared, which equals 4 pi times 1/2, which equals 2 pi. And the problem said that the dimensions are in meters, so this is going to be meters squared. 2 pi meters squared. That's the area of the semicircle. Okay, now we have this rectangle. We know that this base from here to all the way here was 7, but from here to here was just 4. So we're going to use this 4. The area of the rectangle is going to equal length times width. The length is going to be 4, and the width is going to be 2 times the radius. See, the radius of the semicircle is halfway down. So all the way down is going to be 2 times the radius. So that's also going to be 4. So 4 times 4 is the area of the rectangle, and that's 16 meters squared. Okay, now we need to find the area of this triangle. The area of a triangle is 1/2 base times height. So we have 1/2. The base is going to be the 7 minus this part. So we just have this part left. So 7 minus 4 is 3. So this base is going to be 3. The height is not 5. 5 is this slant height. Okay, we're going to use that when we do perimeter, but right now we're doing area. So for the height, we're actually going to use this measure, which once again is 2 times the radius. So that's 4. So we have 1/2 times 3 times 4. We actually already did that. So that's 6 meters squared. So the total area is going to equal 2 pi plus 16 plus 6, which is going to be 22, that's 16 plus 6, plus 2 pi meters squared. Okay? You can leave it like this. If you decided if this bugs you and you want to pull it out, then 2 times pi is going to be approximately 6.28. So we can say it approximately equals 22 plus 6.28, which is approximately 28.28 meters squared. This is not exact because pi is not exactly 3.14. So 2 times pi is not exactly 6.28. So this is approximately 28.28 meters squared. This is exact because it includes all the decimal places after pi. This is approximate. Okay? Now let's do the perimeter. For the perimeter of this part, we can just talk about the space around here. So we've got 4 plus 5 plus 7. So the perimeter is going to equal 4 plus 5 plus 7, and then it's going to be the circumference of this half circle. The circumference of a circle, we're going to do circumference of a half circle. The circumference of a circle is 2 pi r, so a half circle is going to be half of that. And half of 2 is just 1, so the circumference of a half circle is just pi times r. In this case, that equals 2 pi. So plus 2 pi. And this is in meters. So we're going to add these together. This is 4 plus 5 is 9 plus 7 is 16 plus 2 pi. So 16 plus 2 pi meters. And that would be the total perimeter. Okay, let's try another example. On page 10 of your book, you're going to look at figure B2. Excuse me, kitty. Okay, we have this figure. Our instructions are to find the area of the shaded portion of this figure, and it says that dimensions are in meters. Okay, so what we have is a rectangle, and inside of the rectangle are cut out portions of a circle and a triangle. So the shaded area is going to be the area of the rectangle minus the area of the circle and the area of the triangle. Okay? So let's start by finding the area of the rectangle all by itself. The area of the rectangle is going to be the width times the height. The width is 10 meters and the height is 15 meters. So the area of the rectangle all by itself is 150 meters squared. From that, we need to subtract the area of the circle and the area of the triangle. The area of the circle is going to be pi r squared, and according to the book, the radius is 4 meters. So the area of the circle is 4 squared times pi, which equals 16 pi meters squared. Okay? The area of the triangle is 1/2 base times height, and it is a right triangle. So we have 1/2 times 6 times 5, which is 1/2 of 30, which equals 15 meters squared. Okay, so the area of the shaded region, area of shade, equals 150 minus 16 pi and minus 15. Okay, 150 minus 15 is 135 minus 16 pi meters squared. This is the exact answer. If we want to put it into a decimal, then it's going to equal approximately, because we're only using approximate values of pi, 84.76. Okay? You can leave it like this. This is also correct. It's approximately, and in both cases we're using meters as a unit, so they're meters squared. Okay, now we're going to talk about volume, which means we're changing from a two-dimensional plane where we can talk about area and we can talk about perimeter into a three-dimensional geometric solid. A geometric solid is a geometric figure that is three-dimensional and therefore takes up space. It has width, it has length, and it also has height. A cube is a three-dimensional geometric figure whose 6 sides are identical squares. Okay, that's our basic geometric shape, or geometric solid. Volume is how much space is inside a geometric solid. Geometric solids whose sides are perpendicular to their bases are called right solids. The volume of a right solid equals the area of its base times its height. So here's a box. Okay? If we were just talking about the area of the base, this is not a product endorsement, by the way. If we were just talking about the area of the rectangle that makes its base, then we would find the area by taking the width times the length, and that would be the area of just the base, right? We're talking about the perimeter, then it's how long you would have to walk all the way around this. For the volume, we need the area of the base, so the length times the width times its height. Okay? Then that will tell us how much space is inside the Kleenex box, assuming it's not filled with Kleenex. And I'm not getting paid by Puffs for the use of that box, although it would be nice. Okay. And in this case, the geometric solid is a right solid because, at least theoretically, before this box got squished, the height and width, the height and the length and the base met at a 90-degree angle. So this would be considered a right solid. So on page 11 in your book, we have some pictures of right solids. Here's a right oval cylinder. So the base the bases of this shape are ovals, but the height meets the base at a 90-degree angle. Here's a right circular cylinder, so the bases are both circles. Here's a right triangular cylinder, so the bases are both triangles, and this is called a prism. Okay, here's a right rectangular cylinder, which is a prism. A prism is a cylinder whose base is a polygon. It has straight lines. Here is a right cylinder. Its base is oddly shaped. It's not really a definable shape. So this is just a right cylinder. Okay? On page 12, we have some objects that are not right cylinders. Okay? Here we have a circular cylinder, but it's not a right circular cylinder because it's tilted. Here is a triangular prism, but it's tilted, so it's not a right triangular prism. Here's a square prism, and here's just a cylinder. Okay, these are not right because the height is not meeting the base at a 90-degree angle. The volume of non-right cylinders is going to equal the area of the base times this perpendicular distance, its altitude. Okay, so it's the perpendicular distance between the bases, and it's perpendicular to the bottom base. So we aren't going to take this distance, the distance on the side, we're going to take this distance. The volume of a cone or a pyramid is 1/3 the volume of a cylinder of the same base and height. Once again, this is a right circular cone. This is not a right circular cone. It is circular, but it's slanted. So the height that's going to count on this one is the perpendicular distance from the base to the top, and not the height through the middle. Okay? So 1/3 the volume of a cylinder. We'll talk about what those formulas actually look like in just a second. If we're talking about a sphere, the volume of the sphere is 2/3 the volume of a right circular cylinder into which the sphere fits. The sphere fits. So if we have a sphere and we put it inside a cylinder, and the cylinder exactly meets its top and its bottom and its sides, so that the radius of the sphere is 2 times the radius of the sphere, is both the width of the cylinder and the height of the cylinder, then the volume of the sphere is going to be 2/3 the volume of that cylinder. And once again, we'll talk about what that looks like in just a second. So, to sum up, if we have a right solid, the volume is the area of the base times the height. If we have a non-right solid, and this would be cylinders or prisms, the volume of a non-right solid would be the area of the base times the altitude. And the altitude is the distance from the bases as a perpendicular line to the bottom base. The volume of a cone or a cylinder is going to be 1/3 the area of the base times the height. Okay? The volume of a sphere is 2/3 the volume of a cylinder. So that's 2/3. The volume of a cylinder, remember, is the area of the base times the height. In this case, the area of the base, it's going to be a circular cylinder, so we're going to find the area of the base by doing pi r squared, right? And the height is going to be 2r. So when we multiply this all through, it's going to be 2 times 2 is 4 over 3 pi, and r squared times r is r cubed. Okay, so this is the formula for the volume of a sphere. Okay, so let's try an example. On page 13, we're going to look at exercise B3, or example B3 rather. We have this funky shaped cylinder. Okay, and the example says to find the volume of the cylinder if the area of the base is 242 meters squared. Okay, the volume of any cylinder equals the area of the base times the height. So the area of the base is 242 meters squared, and the book says that the height is 10 meters, so the volume is going to equal 242 times 10, which is 2,420 meters cubed. Okay? Let's try another one. Find the volume of this cone. So for example B4, we have this funky cone. It's obviously not a right cone, and its bottom is a squiggly shape, not a circle or an oval or anything useful. So they tell us that the area of the base is 242 meters squared, and the height is 10 meters again. Okay, because this is a cone, not a cylinder, we remember that the volume for the formula for the volume of a cone is 1/3 of the volume of a cylinder, and the volume of the cylinder would be the area of the base times the height. In this case, for height, we're going to use the altitude because it's not a right solid. Okay, so it's going to be 1/3 times 242 times the altitude, and in the book they tell us that the altitude is 10. So this is going to be 2,420 divided by 3, which as it turns out is 806.67 meters cubed. Okay? Find the volume of a sphere whose radius is 3 centimeters. The volume of a sphere is 4/3 pi r cubed. Remember? So, if we plug this in, the radius is 3, so 3 cubed is 27. So this will be 4/3 pi times 27. We can factor out a 3 here, and this becomes a 9, so this is going to equal 36 pi meters cubed. You can leave it in this form. Okay? Okay, now let's talk about surface area. The surface area of a geometric solid is the sum of all the areas of the faces of the solid if it has flat faces. Curved faces are a little different. We'll talk about those in a minute. So starting with geometric solids with flat faces, here's example B6, and we have this right prism. You see the base is a rectangle. The right and left sides are triangles, and this front side and the back side are both rectangles. So the surface area is just going to be the area of the sum of the area of all of the faces. So the bottom 2, 3, 4, 5 faces. So the area of the triangles, and there are 2 of them. Area of the triangle, and then there are 3 rectangles. So the area of the triangles is 1/2 base times height. These triangles are actually equal. So that's going to be 1/2 4 times 3, which equals 6. And these are in centimeters squared. This is also going to be 6 centimeters squared because the two triangles on either side are equal. Okay? The area of the base is a rectangle. So its area is length times width. In this case, its length is 3 and its width is 6. So that's going to equal 18 centimeters squared. The area of the front it's a rectangle, so it's also length times width. Its length is 6 and its width is 5. So that's going to be 30 centimeters squared. The area of the back rectangle is going to be length times width, and its length is 6 and its width is 4. That's 24 centimeters squared. So the surface area, I have run out of space. The surface area is the sum of all of these. So it's going to be 6 plus 6 plus 18 plus 30 plus 24, which equals 84 centimeters squared. Okay? Okay, let's try another one. Example B7. We're going to find the surface area of the right circular cylinder ship. Dimensions are in meters. Okay, so this is a right circular cylinder. Now we have a curved side, and we need to find the area of this curved side. So we need the area of the two bases. The bases are both circles. So the area of the bases is going to be pi r squared. And then this curved side, to find the area of a curved side, we have to find something called the lateral surface area. In this case, the lateral surface area is just like unwrapping this cylinder and pulling out into a rectangle. So now we've got the height of the cylinder times the circumference of this circle, which is going to be the length here. Okay? So the lateral surface area is the height times the circumference or perimeter of the bases. So let's figure that out. So first of all, we have the area of the bases, and we have two bases. They're going to be exactly the same. The area of the base is pi r squared because it's a circle. The radius was 4, so this is going to be pi times 4 squared, which equals 16 pi meters squared. There are two bases. So if that was base 1, this is base 2, and it's going to be exactly the same. So it's 16 pi meters squared. The area of the curved side, the lateral surface area, is, we find it by multiplying the lateral surface area. We multiply by multiplying the height of the cylinder times the circumference of the base. The height of the cylinder is 10 meters. The book told us that. And the circumference of the base is going to be the circumference of the circle, which is 2 pi r. Okay? Which is going to equal 10 times 2 times pi times 4, because that was the radius of the circle. So we have 10 times 2 is 20 times 4 is 80, which equals 80 pi meters squared. Okay? So the total surface area is going to be the sum of all of these. So it's going to be 16 pi plus 16 pi plus 80 pi, which equals 112 pi meters squared. Okay? Take everything one little step at a time. Here's one more example. The base of a right cylinder 10 feet high is shown. Find the surface area of the solid. Dimensions are in feet. Okay, once again we have a complex shape, so we're going to break it up into parts. Here we have a half circle and a rectangle. So the first thing we need to find is the area of the base. The area of the base is going to be the area of the rectangle plus the area of the half circle. The area of this rectangle is just going to be 6 times 5. The area of the half circle is going to be 1/2 the area of a circle, which is pi r squared. So this is going to be 1/2 pi r squared. The r is 3. Okay, so we have 30 plus, this is 9 times 1/2, so 9/2 pi feet squared. Okay, so that's the area of one base. It's ugly, but it's correct. Excuse me, there are 2 bases, of course, and they're both going to have the same. And now we need to find the lateral surface area. I'm just going to write LSA. That stands for lateral surface area. So lateral surface area of any right solid equals the perimeter of the base times the height. So now we need to find the perimeter. The perimeter of this base is going to be 5 plus 6 plus 5. 5 plus 6 plus 5 plus the circumference of this half circle. The circumference of the circle is 2 pi r. This is a half circle, so it's only going to be 1 pi r, or pi r. The radius is 3, so this is going to be 16 plus 3 pi feet. Okay? So that's the perimeter. And we're going to multiply the perimeter times the height, which was 10 feet. So that'll make this 160 plus 30 pi feet squared. Okay, that's 10 times 16 plus 3 pi. Okay, now to find the total surface area, we need to add both the bases and the lateral surface area together. So the area of the bases was 30 plus 9/2 pi plus 30 plus 9/2 pi plus 16 plus 3 pi. Okay, so this is 76 plus 9/2 plus 9/2 is 18/2, which is 9. So 9 pi plus 3 pi is 12 pi. What did I do? Sorry, back that up. This is 160 plus 30 pi. I used the wrong thing. Sorry, backing up. So we have 30 plus 9/2 pi plus 30 plus 9/2 pi plus 160 plus 30 pi. Okay, 30 plus 30 plus 160 is 220. 9/2 pi plus 9/2 pi is 18/2 pi, which is 9 pi, plus 30 pi is 39 pi feet squared. And that would be your answer. You do not need to pull this out into a decimal. You can, but you don't have to. Okay? Alright, here are a few special cases. The surface area of a sphere, we're going to find that by doing 4 pi r squared. That's how you're going to find the surface area of a sphere. The lateral surface area of a right circular cone is pi r s, where s is the slant height. Okay, so if we have a cone, when we find the lateral surface area, we are not going to use the altitude on the inside. We're actually going to use the slant height. So the lateral surface area is going to be pi times r, which is the radius of the base, times the slant height. Okay? If we find the area of a pyramid, the lateral surface area of a pyramid is the sum of the area of all the faces of the pyramid, not including the base, because we're just doing the lateral surface area. So the lateral surface of a pyramid, so these are triangles, so it's going to be 1/2 the base times, and once again we're going to use the slant height, not the height of the actual pyramid, but the slant height, because that's the height of these triangles. Okay? So 1/2 base times slant height for the area of one face. And then your lateral surface area is going to be the sum of all the faces. To find the total surface area, you're going to find the lateral surface area, so the sum of the areas of the base, of the faces, the sum of the area of the faces plus the area of the base, and that's going to be the total surface area. Okay, this lateral surface area of the right circular cone is going to be the lateral surface area, which is pi times the radius times the slant height. And then to get the total surface area, you're going to add the surface of the base. Okay, sectors of a circle and arcs. One part of a circle, meaning the outside part here, one part of a circle is called an arc. If we draw two radiuses, coming from the center of the circle out to the arc, then the area inside those two radii are called a sector. The degree measure of an arc is the same as the degree measure of the central angle formed by the radii. So when we talk about the length of an arc, we're going to talk about it in degrees. Well, that's one of the ways we're going to talk about it. So we are going to talk about it in degrees, and it's going to be degrees from this radius to this radius. And it's going to be the same as the angle in between here. Okay? There are 360 degrees in a circle. A 1 degree arc is 1 360th of a circle. Okay? So a 27 degree arc is 27 360ths of a circle. The sector designated by 27 degrees of an arc is 27 over 360 of a circle. So if this is 27 degrees, then this is 27 360ths of the entire circle. The length of a 27 degree arc is 27 over 360ths of the circumference of the circle. So if the radius of a circle is 6 meters over here, the area of the circle is pi times pi r squared, so pi times 6 squared, which is 36, so that would be 36 pi meters squared. The circumference of the circle is going to be 2 times pi times r, so that would be 12 pi meters. The area of a 27 degree sector is going to be 27 over 360 times the area of the whole circle, 36 pi meters squared. Okay? Which, when you work it all out, comes out to 2.7 pi meters squared. The length of the 27-degree arc is going to be 27 over 360 times 12 pi, because that's the circumference of the circle. And when you work this all out, it comes out to 9/10 pi meters. Okay? So let's try this example. The radius of this circle is 10 centimeters. Find the length of a 45-degree arc and the area of the 45-degree sector. So assuming this is a 45-degree arc, and therefore this is a 45-degree sector, we should be able to find the length of the arc and the area inside. Okay, so the area of the circle is pi r squared, which is going to be pi times 10 squared, which is 100 pi centimeters squared. The circumference of the circle is 2 pi r. It's going to be 2 times pi times 10, which equals 20 pi centimeters. Okay? If this is the area of the circle, then the area of the sector is going to be 45 over 360 times 100 pi, and that's going to be 4,500 over 360. We can take out 2 of those. There's a pi on the end. We can divide both of those by 9 and get 50 over 4 pi, which equals 25 over 2 pi centimeters squared. So this is the area of the sector. Okay? 25 halves pi. Okay? The length of the sector, or the length of the arc rather, is going to be 45 over 360 times the circumference of the circle, which is 20 pi. Okay, so 20 times 45 is 900 over 360 pi. We can take out a 0 on both sides, and once again we can divide both sides by 9. We get 10 over 4 pi, which equals 5 over 2 pi centimeters. And that is the length of the arc.